cool things that didn't quite fit in another video. So let's say that we have our scene of a column of cubes and a column of spheres, and we want to randomize the vertex positions of these things a little bit. And we want to leave the original object maker untouched. So I've got a little random node right here, which is going to take whatever's selected, right? And it'll just randomize the local Z translate. So I will take and parent that in under my object maker, and you can see that it gets slotted in under every instance of object maker. And this random thing just basically gets dropped in there. So now if we run this, we'll execute, and we'll see that it is basically working, except it's only happening to the first object that we're creating. And that's because it's selection based right now. So what we need is a method to run the random node on each of the objects that we've built. And there'll probably be a better design pattern for what we're actually trying to do here, but this is a good example. So what we really need is a way of tracking the objects that we've made and then making them available to other nodes, right? Now, so I will make a new attribute on my object maker. I think I'll just call this results. Okay. And then in the code block here, I'm going to build a list to store that. And for every object that I get back, I'm just going to append the object to my result list. And when we're done, we'll just print out the result list. So let's execute the code and see what we've got here. So now you can see that for each node, so when I execute my spheres node, it shows that I'm building sphere 1, sphere 2, and sphere 3, as well as p cube 1, 2, and 3, and then finally p sphere 4, 5, and 6. And this should basically be running the same. So we've successfully added these spheres, or these objects, to a list. Well, what I want to do next is basically take the results of this list and stuff them back into this attribute and make them available down the line. So the way we're going to do that is access the node itself through the self convention. And we'll just say self.results will equal the result list. Okay. Now when we execute this, this will be the first time that we'll be able to take advantage of our cached view here. And I've run this, and I don't see anything in my results here, even in the cached view. But if I come over to my actual scene, the nodes that actually got executed, like the cubes here, we'll see that my results list is now populated with those values, and they are available as attributes to their children. So I'm sure you can see where we're going with this. Now I can use the results attribute that's been inherited down, and then I can, let me come back out of cached view here, and we'll pop over to Maya, and we can see now that we've got randomization on all of our spheres and cubes. Don't want to leave them out. Okay, so what we've done here is looked and to see how a child of an instance gets executed, and then how we can push data back in using the self convention, and again how we can use the cached view to inspect that data after we've executed it one time on the graph.